Okay, example 6 for internal flow convection, force convection, heating of water in tube by steam. So let's take a look at the question. Water enters a 2.5 centimeter internal diameter thin copper tube of a heat exchanger at 15 degrees Celsius at a rate of 0.3 kilogram per second and is heated by steam condensing outside at 120 degrees Celsius. If the average heat transfer coefficient is 800 watt per meter square dot Kelvin, determine the length of the tube required in order to heat the water to 115 degrees Celsius. So now, from the question, we already know that the diameter of the thin copper tube is 2.5 centimeter. So, and this is for internal diameter. Okay, we already been given the internal diameter 2.5 centimeter. And then inlet temperature for the water is at 15 degrees Celsius. Then the exit temperature for the water from the pipes is 115 degrees Celsius. So this is the exit. And the steam outside of the fluid, outside of the tube is at 120 degrees Celsius. Okay, so determine the length of the tube required in order to heat water to 150 degrees Celsius. So in this figure, in this question, length of the water, length of the tube is not been given. Therefore, that is our objective, to find length of this cylinder tube. Okay, thin copper tube. Okay, then properties of water will be evaluated at bulk mean temperature. So bulk mean temperature equation is Ti, so Tb, T bulk equation is T inlet plus with T exit divided by 2. Now we have T inlet at 15 degree. We must add with 115 degrees Celsius. So this is degrees Celsius divided by 2. Therefore, you will get 65 degrees Celsius. So you have to evaluate all the properties at 65 degrees Celsius and not at 15 or 115 degrees Celsius. So at this point, we want to find what is the CP of water. And the heat of condensation of steam at 120 degrees Celsius. Okay, 2203. So 120 degrees Celsius is the phase temperature. Okay, let me explain about Ts. Previously, I already mentioned that Ts is Tsi for the question, for the equation in internal force convection. But here, why do this question takes Tsi as 120 degrees Celsius? And we know that the steam condensing outside is at 120 degrees. Take a look at the question. Here, the question mentioned about thin copper tube. When the question mentioned about this or state about thin copper tube, therefore Di is equal to Di. When this equal, So we can say that Ts at outer surface also is equivalent to T at inlet surface. So T surface at out is equivalent to T surface at inner surface lah. Okay, in. Because of the thin copper tube, Di is equivalent to Do. Therefore, Ts out is equal to Tsi. Then this Ts is actually Tsi. Okay, because we have to find what is the heat of condensation of steam at 100 degrees Celsius, because in the question, in the equation, we required this information in order to calculate Nusselt number or any other properties that we want to calculate. Okay. Now, this is previously I already mentioned that there are two conditions where we have constant surface heat flux. Okay, and second is constant surface temperature. Now this question falls under constant surface temperature. There is no external electrical resistance or radiations from outside to the system. If there is electrical heater, or there is a radiation to this system, therefore this condition falls under CSHF, constant surface heat flux or constant heat flux. Okay, and then this falls under constant surface temperature. So under the constant surface temperature, we have this information equation that can be used in order to find rate of heat transfer. So Q dot equal to mCp, this is delta T, and HA as delta T log mean temperature difference. So to find delta T log mean, we have this equation Ti minus Te over ln Ts minus Te divided by Ts minus Ti. So in the short form, you have these kinds of equation. Okay. Now in this question, we already been given with the information given is 800 watt per meter square dot Kelvin. This is average heat transfer coefficient H. So we do have H here. As, we cannot find As because we have to find what is the length, but we still can calculate As, but we will leave it with unknown L. Okay. Now, what about m dot Cp delta T? Yes, m dot mass flow rate is given in the question, 0.3 kilogram per second. And then Cp is from the bulk temperature. Okay, that is why we have to find what is the bulk specific heat of water at bulk temperature for 187, and then we already have this. What about Te? Te here is T exit minus T inlet. Okay, and from this figure we know that the T exit is already been given and also T inlet. So we can find Q dot by using m dot Cp delta T equation. And then what about delta T log mean? So let's take a look at the equation for delta T log mean. Do we have Ti? Yes. What about Te? Yes. Ts? Yes. Te? Yes. Ts also? Yes. Yes. So we can solve the delta T log mean, and then this delta log mean can be found. So let's refer to this question. This question asks about the length of the tube. Then from this equation, if we equate m dot Cp delta T with HAS delta T log mean, we can leave the right hand side of this question with unknown L. Then if we rearrange this equation, we will get L is equal to what? Okay, for the first step, we have to calculate what is m dot Cp delta T. So Q dot, we know that Q dot is equivalent to m dot Cp delta T. So now our m dot is 0.3 kilogram per second times with Cp. What is Cp? 4187 joule per kilogram dot Kelvin. So 4187 joule per kilogram dot Kelvin and times with 115 minus 50. So we will get this 1256 watt or 1256 kilowatt. One to 5.6. Sorry. Oh, this is sorry. 1 to 5. Yes. 125,600. This is 125.6. 125.6 kilowatt. So we already know the rate of heat transfer for this system. Okay, it is actually Q heat has been transferred from 115. From outside to the system. So this figure. So we know that the Q has been transferred from surrounding 120 degree to this system. So we have T exit and T inlet. So the Q value for this is equivalent to Q value for this is 125.6 kilowatt. So we know that the Q is constant. Whatever Q that been transferred or absorbed by the system. So this Q is actually absorbed from, we have TE and TI. So we calculate how much energy has been absorbed by this fluid, from the fluid. If we want to equate with the Q from the outside, so we want to find what is the heat transfer coefficient, or we want to find what is the length, so we can equate with the equation of this convection heat transfer coefficient, convection heat transfer. So where we have to find what is the delta log mean. So now we have H, we can find AS equation. Then we do calculate for this delta T log mean. So let's calculate delta T log mean. So we have delta TE. Delta TE is equal to TS minus TE. Okay, this is 120 degrees Celsius minus 115 degrees Celsius. you will have 5 degrees Celsius. Next, we have to find what is delta Ti. Okay, Ts minus Ti equal to 120 degrees Celsius minus 15 degrees Celsius. We will get 105 degrees Celsius. Next, substitute into delta T log min or delta T ln. So delta Te, so the equation is delta Te minus delta Ti divided by ln, so delta Te divided by delta Ti. Okay, so substitute all the values that we get from this. So delta Te is 5 minus 105, this is degrees Celsius, and then divided by ln, so we have delta Te 5 degrees Celsius divided by 105 degrees Celsius. We can cancel out this. So we will get 32.85 degrees Celsius. So we already solved for delta T log min. Next, what we are going to do is we have to equate the equation for Q, where Q equal to m dot Cp delta T equal to H as delta T log min. So m dot Cp, okay, delta T is equal to H as delta T log min. Now we take a look at the AS. We already know the value of this. We substitute 1 to 5.6 kilowatt equal to H as delta T log min. To calculate, please make sure that the kilo here is converted into times 10 to the power of 3. Like this. So 6 times 10 to the power of 3 watt. So let's take a look at H. We have H value that is equivalent to 0.8 or 800. So 125.6 times 10 to the power of 3 watt equal to, so here we have H value is 800. So 800 watt per meter square dot Kelvin times with AS. So I write the equation here. So we know that AS is pi dl. So L will be unknown because this is our objective. So therefore we will make it unknown till we get we rearrange the equation. So I substitute the value by D is 0.025 meter and then times with L, and for delta T log min is equivalent to 32.85 degrees Celsius. So rearrange all of this equation to get what is L. So L is equivalent to 61 meter. Okay, so we already answered the question. Okay, thank you.